Hello to everyone for our sixth webinar for the FAIRWork project. That's the title towards DAI-DSS technical enriched status report on the FAIRWork project. So this is what we will do. The work on the FAIRWork project is progressing, and I will be the moderator. And my first point will give to Robert, and he will introduce the idea of the project. Thank you.
Yes, thank you very much, Christian. As you can see here, the project idea is the following: that in the middle you see a person, and we still talk about a person who makes a decision, and this person should be supported by a decision support system. So that's a typical step. We have data and information at the very bottom. For example, personal needs. You can think of sensors, personal sensors, wearables, or IoT. Sensors or apps, and some other information devices. You can have condition monitoring of vehicles, self-driving vehicles in a factory, or robots and line configurations. And all these information plus more is collected in what we call a knowledge base. And there will be from Jotne a presentation on the knowledge base. We will then have an orchestration where bringing human, artificial intelligence, data, and robotics together in a manageable way, as we say. There is a framework which we call OLIF, and we will also see this from VOC as a prototype. And at the very end, you have what we call democratic AI-based decision support system, a user interface that actually supports this person making decisions. Now, so far, it's a traditional decision support system. We enrich it on the right side with artificial intelligence, and there will be a presentation from RWTH Aachen saying which type of artificial intelligence can be introduced to make this classic decision support system an AI-based decision support system, including human aspects like the expert knowledge in collaboration, including data lakes and data fusions, and of course, the artificial intelligence. So that enriches the whole system with artificial intelligence. And what is mentioned here with democratic AI means that it's a decentralized approach. So it's not one centralized repository that makes all these, let's say, decision supports, but it's a decentralized approach where different agents on different places also have a word. Of course, not everything can be overruled, but some aspects can be influenced. And in order to make this decentralized approach somehow manageable, you need the left side, which is a configuration environment. You have models which bring in what we call context into the system, and there will also be a phase where we can say how we deal with decision trees, and there are also some other approaches like fuzzy logic, semantic, etc., to bring these decisions context in. There are methods and guidelines and experimentation laboratories to test the different behaviors, and don't only focus on technical aspects, but also on human, social, and experimentation aspects. So I would like to close with the next slide, this introduction, by introducing the consortium. Basically, we have BOC, which is a company from Austria dealing with this modeling approach and configuration of knowledge. There is another company called Jotne from Norway dealing with data lakes, and this whole knowledge base. And then we have strong research approaches like RWTH Aachen, which also hosts this meeting in artificial intelligence and human technology interaction. There is Uranium Research, again, research center from Austria dealing with data lakes and all these IoT human laboratory aspects. We have more collab with this decentralized approach following the agents. And then we have our two use case partners, CRF in the context of Stellantis, a car manufacturer, where we also see some aspects of use cases on resource allocation on the production line, and Flex, a producer of several parts, in that sample electronic parts, where robots are used for test automation. And as a communication, distribution, and collaboration partner, we have the nonprofit organization network OMILAB, which hosts this meeting and is contact person for all these community issues. So thank you very much. And now I think we listen to the research aspects.
Yeah, as Robert said, we now come to the research concept. Therefore, we'll give to my colleague, Professor Böschner, who starts with identifying green factors.
Yeah, as named, this decentralized approach is really basing on the question, what does democracy mean in an industrial context? So it's about, therefore, identifying human factors relevant for AI technology. But it's really important to see at the same time that it's not only about creating factors and thereby representing humans via technology. It's also about the question, what are the forms and limits, the options and the restrictions with regard to being represented by technology? And where are the cases where humans have to speak for themselves to say, well, that's really democracy here in our technology development and decision-taking and production lines. So against this background, we really ground our research in research on cases. A case study approach is really important with regard to being able to identify practices, to really have a deep insight into what is going on at the ground, on site. What is there? And to do so, as it is really, it's really a time-consuming form of research, we conduct this research in a way that we say, well, we have lead cases and we have focused cases. So the lead case is about really creating an environment where we see more or less all of the relevant aspects we would like to see. And then we have cases where we can test these first insights and contextualize whether we are right or not, and where we have to appropriate, better improve the things we found so far. So, and you see here the three phases we defined against this background. It's an onboarding phase, a precision phase, and the contextualization phase. And they are related to specific goals that we have. If you go to this onboarding phase, is about really coming to contact to the cases and create an environment where we can co-work really together and to gain first insights as well. And with regard to the precision phase, it's about gaining insights into really the cases, but not only the cases, also other factors, aspects we see or have identified as really relevant. And therefore, we would like to do, and that's really a strength of this consortium, that we can do in-depth research by having on-site interviews, laboratory experiments, and online experiments and interviews as well. So we combine these different forms of research to really be able to combine and really to explore the relevant aspects, which at the end, that's the third phase, we try then to contextualize the insights as we then have on-site discussions, workshops, where we discuss the results within our empirical research, which then will be implemented into the technological system. And therefore, the question here is whether this fits appropriately into the ways decisions should be taken in the daily business. And so that's really an important thing to see here, and then also to see whether there are specific restrictions and legitimation questions we should have, or we should take into account.
Thank you. Then next will be our colleague Sylvia, who goes on the identification of research factors.
Thank you, Christian. And thank you, Stefan. I would use this opportunity and dive deeper into technology and into the AI and math systems, so artificial intelligence and multi-agent systems, which we want to apply in this project. When it comes to research in these two domains, we needed to identify which factors which factors are the most important for our research to be actually completed in our use cases. So you can see on the slide the 3 main use cases and the research requirements that we identified in order to put use these methodologies. I want to underline and really show the importance of the relevant data, because without data we cannot actually develop and validate data-driven models. Decision support system architecture is the second factor, is also really important to perform our modeling. Expert knowledge, because we cannot forget about a human, we cannot forget that some models actually need a human input, and as well decision models, which means here the decision paths which are taken every day by a certain person. So basically, what steps in mind the person is doing actually to take the decision. We need all of it together to put model and perform research in this direction. So therefore, taking into account these factors, we identify some of our AI services that could be a potential solutions to the use cases which you can see in this table. So I would like to keep it short and hand it over to Gustavo.
Thank you, Sylvia. Following, I would like to present some last possible applications in industrial scenarios in testing data with our industrial partners. First, a series of resource allocation applications. A recurrent challenge found in the manufacturing industry regards workers allocation. Unexpected changes in the availability of workers as for medical reasons, for instance, can generate disruption in the production chain. Based on a mapping of workers' capabilities regarding the execution of tasks and access to workers' availability, the production plan can be redrawn in order to adapt to a new configuration. Structuring the system under the perspective of multi-agents allows access to this data distributed among different human and non-human entities through a structure that can correlate this data among the players. Not much differently, workload balance problems deal with equalizing resource utilization. When the human individuals on the shop floor are digitized and their physical and mental conditions can be sensed, when their wishes can be related to the actual production plan, the multi-agent systems connects these distributed components across the shop floor and provides a means for this information exchange while granting autonomy to how this exchange occurs. An issue commonly found in many industries, as in manufacturing, is the disruption of production due to machine breakdown. This type of issue can be tackled by different approaches. One of them is proposed here, and it deals with the allocation of resources, aiming to keep the production plan as close as the original as possible. MAS can process the environment conditions and recommend rearrangements of machines in a reasonable time, and the shop floor gives the flexibility requirements it needs to work. Also, a possible application of MAS to a machine maintenance scenario encompasses the simulation of the machine conditions based on parameters historically related to breakdowns. Simulation can provide timely maintenance recommendations in order to prevent unexpected downtime from occurring and affecting the production plan. It also offers the possibility to check what types of tasks the machine can perform before it needs any maintenance, and thus extend its uptime. Supply chains need to cope with high volatility of production demands and availability of material to produce. In order to avoid bottlenecks in production, an agent-based simulation offers a framework to organize and schedule material handling in advance. Different settings can be experimented with through modeling the system with agents with data regarding material availability and production expectation for the near future. The development of multi-agent system is an interactive process that takes into consideration the particularities of each challenge in question. After identifying these items and goals we want to achieve, we start modeling the system, developing it based on the first observations, and from that, adapting the model based on the conclusions obtained in these first tests. After this first cycle is complete, we can deploy the system with an increased level of maturity, and this process is repeated temporarily throughout the project. So you ask, how can multi-agent systems be designed to ensure a democratic decision-making process in the industry? How can MAS contribute to enhance worker participation in the decision-making in the industry. In other words, how can mass promote on worker impact in industry processes based on data collected from the human? Also, how to properly model the human information that enables the agents to concretely and definitely behave on the behalf of the human. How to transmit outcome and decision confidence from mass to the human. The trust factor is also an important matter that needs to be addressed. Ensuring that the human trust in the system is essential for the success of the project, needed by modeling the human information to the agents or transmitting decision confidence from the system to the human. Thank you.
Thank you very much. So our next point is, as we make decisions involving humans, so we should not forget the humans, and therefore, Lucas will now explain how we keep the human in the loop.
Yes, thank you. The human actors, they are engaged in this overall decision-making process, and this is in the manner of a human in the loop condition. And a decision-making manager might act under stress and will, for example, apply different strategic decisions that potentially change the quality of the overall process. And the worker at the shop floor might suffer and be overcharged with physiological strain, and consequently errors might apply. And the health status of the person can be impacted to require outage for days. So it's next slide, please. And for this reason, we will equip decision makers and workers with the state-of-the-art wearable technology, like biosensor shirts, eye tracking glasses, and smart bands. The goal is then to digitally estimate their cognitive, mental, and motivational state by means of explainable AI with trustworthiness and transparent operation. And from this derive a performance and risk classification upon the physical and cognitive, particularly also readiness at any time instant. Next slide, please. And here you can see our latest state of progress, a dashboard for researchers and developers. It displays continuously all parameters that are key to estimate the physiological strain. It's the first step. And applies analytics in real time. It transfers this raw data into risk levels that relate to long-term or even short-term damage of the worker's health condition. Based on the actual state of the system, we'll be able to apply recommendations probably to positively influence, like arrest by recommending arrest or evaluation, supply, and in the next progress step, we will work on towards cognitive emotional strain management. Thank you.
Thank you very much. So the next big part of our webinar is now the end user scenarios. So the scenarios in which we want to apply our decision support system, our AI-based decision support system. We have two project partners here and Flex, but before we come to them, I just want to shortly introduce how we got this information out of them. So we have defined now our cases where we want to support this decision. So what are the situations where decisions can be supported? And you see here on the right top this process that we use to do this. If you are interested in this process in more detail, this is discussed in the webinar in March. So what I want to say now is what the future state will be is that we have different parts where we have on the first we have to understand the decision what should be made. Then we integrating with the persons who make the decisions or are influenced by the decisions. Then we have to specify what we exactly want to decide. Then we have to translate this in our technical infrastructure so that we can use our AI services, our multi-agent systems to support the decision making. And for all the stages, different tools will be applied. And one specific important factor will be here modeling, that we use models, conceptual models, to capture the knowledge so that it can be understood by humans who are influenced by the decision and who must make the decision. And there we have different tools like the simple model tool, which will be adapted to this process, or also Adonis, where we can have business processes designed and modeled to understand these decisions. So it will also be part of our project. But the next part now will give over to Flex. Here our first partner with the use case scenario. Thank you.
So, okay, in principle, we have decided for 3 use cases. The first is initiation of a new project. That means we want to replace a manual process with robots. And therefore, this project should support to support the automation engineer to have the right solution, to have the right method of robot systems, collaborative, industrial, or in cooperation mode. And also the system should help us to consider all safety requirements, what is necessary. The environmental of the factory means people, transport ways, good transport ways, space, design of the, how can I say, of the system. And also there should be a second path to support them is to have simulations with digital twin to find in a very short way the right solution for this. The second approach or the second use case is the worker allocation. Let's mention this. So in case of we have fallout of suddenly fallout of a worker, that we can replace this worker in a very quick time. Not searching only on the line, because the line manager has only the information of the skills of his line. We want to search over the whole factory, which worker is available, which workers have the skills, and also where we have less, how can I say, influence to other product timelines, to find a good solution to close this gap for delivery delay as much as possible. And the third one is for maintenance, to have a knowledge database for not so very well experienced or new maintenance guys, to find a way or to support them to find the right solution, to give the right answers, for example, for downtime, estimated downtime on the line, to make the right decisions, then to wait or to shift it to another production line, let's say. Okay, thank you.
Thank you, Roland, for your input from Flex. Now, our second use case partner is CRF, and here we have Alessandro, who will further introduce it.
Thank you, Christian. CRF is working with partners to explicit and formalize its case study on Migafiori Pest Shop. In recent months, 2 main activities have been carried out. The first is the sharing of the information about the decision-making process, the model line, designed to define decision models. In parallel, examples of the data were provided, extracted from the plant in the system, which are used to feed the decision models. The activities concern the 3 previously defined scenarios, so the workload balance, how to allocate people in a way, the delay of materials, so how to avoid the missed production delays, and the third one is the quality issue. In particular, we are focusing on the first one, the workload balance, because the first demonstration is focused on this one.
Thank you very much. So now that we know our end user scenarios, Marlene will now introduce. I will now introduce the decision processes.
Exactly. So here you can see one example for a decision process model regarding the use case of CRF, workload balance. And so now we specified the prior formalized business processes of CRF and using components and using DPMM. And how did we approach this? We were actually always asking or keeping in mind 2 questions. The first one is who was the relevant decision maker in this scenario, what should be the outcome of the specific decision-making process, and the third question is which aspect and parameters must be considered by the decision makers to find a solution. So the problem setting for the CRF workload balance is that not every work is allowed to produce every geometry, and this must be considered by the decision maker. So the outputs or the outcomes of the decision-making process would now be to either allocate a worker to a line or dismiss its work, or don't allocate a worker to a line. And as you can see, those yellow boxes, they indicate parameters that are considered by the decision maker in order to get to the final output. Like, for example, is the worker available or not? What are the medical conditions for the worker? Does he have experience with the line, and so on? And we need those decision models to serve as a common base to bring not only context into the system, but also to serve as a common base to bring the knowledge of IT specialists, researchers, and also domain experts together. And also another additional aspect of these decision models is that they can now be used for further technical considerations, like, for example, where can they be enhanced, which decision gateway can be substituted or done by the AI service, and so on. So thanks. Was the one example process.
Thank you. And the next part is now the implementation. So of course, decision support system needs an implementation. There we will start with the high-level architecture presented by Magdalena.
Yeah, thank you. So regarding the implementation, we defined the high-level architecture for our decision support system. So in the slide, you can see the different components of the system. On the bottom, we have the knowledge base component, which stores the data coming from the production environment. Besides the raw data, also knowledge can be stored inside, and this knowledge can come from processes and models created by humans or from AI-enriched services. So on the right side, we have an AI service catalog, which includes different types of AIs, like data-driven, knowledge-driven, or distributed AI, and they are there to support the decision maker. These services need to be configured and orchestrated, and in the end, the result is visualized in form of dashboards. If you are interested in this topic, there was already another FAIRWork webinar in April about the introduction to the high-level architecture for FAIRWork, and the recording can be watched on YouTube. You can see the link in the slides. And in this work package regarding the implementation, we focus now on the development of an initial prototype, which is of course based on this architecture, and this work is ongoing, but regarding the knowledge base, we can already present some progress, and my colleague will show you more regarding this topic.
Thank you.
Yeah, thank you, Magdalena. And as we know, knowledge base is the central data repository in the FAIRWork architecture, where all the relevant data from sensors, machines, and humans are collected and stored. So basically, this knowledge base is implemented using ISO 10303 step standard. This is the core of our knowledge base. This standard, all the data and the product data exchange is done using this standard. And furthermore, the knowledge base offers capability to store both structured and unstructured data. So having both kind of data in the same place enables it as acting as a data lake. And furthermore, in the knowledge base, using reference data values, we can digitally represent the physical entities by modeling their attributes. In the next slide, we can see how this can be done. Here, this is you can see on the right-hand side of the 2D plant layout of an use case partner CRF. On the image, you can see we have 3 units, UT1, UT4, and UT8. On these units, we have certain lines, and each line can produce certain geometries. And these geometries require certain number of operators to work on, and they have some material requirements like raw material code and line configuration, like what are the dies required to produce this geometry. So what we want to do is we want to capture this information and store it in the knowledge base. On the right hand side, you can see the implemented digital replica of this 2D plant layout, where you can see the open connection graph of these components. The main component is the CRF. Under CRF, we have 3 units, UT1 and UT4 and UT8. Under these 3 units, we have furthermore the lines. And in these lines, we have all the required geometry and their configuration information. And to get this information, we can use the REST API services provided by the knowledge base. Underneath, you can see the API response from the REST API call. Here you can see the geometric information obtained from this knowledge base. So the other components in the DAI-DSS knowledge base can use DAI-DSS can use the API services provided by the knowledge base, and this data can be used for further decision making. Thank you.
Thank you very much. So this was our status update. We would like to keep in touch. If you find something interesting from one of our partners, you can of course contact us. Here are information. If you want more information, we have also a LinkedIn profile and a web page where we have, which is constantly updated. But in this case, I want to thank you for your attention.